So in this video I want to talk about how to rationalize the denominator of a fraction. But before I do that, I want to make sure that you know these rules when it comes to surds or radicals. And the first rule says that if I take the nth root of x to the m, so if I have x to the m and I take the nth root of that, that's the same as x to the m over n power. So for instance, the cube root of 7 squared, so if I take 7 squared and then find the cube root of that, that means exactly the same thing as 7 to the 2 over 3. Also, the square root of a times the square root of b is equal to the square root of ab. So in other words, the square root of 2 times the square root of 3 is the square root of 6. And we're going to use these rules when it comes to simplifying or rationalizing the denominators of fractions. So let's look at our first example. So we've got to rationalize the denominator of 1 over root 3. We have to make this lower number rational. So to do that, I'm going to multiply the top and the bottom by root 3. So 1 over root 3 is the same as 1 over root 3 times root 3 over root 3. I'm allowed to do this because I'm multiplying the top and the bottom by the same thing. So 1 times root 3 is just root 3, and on the bottom I've got root 3 times root 3, which is just 3. So I've got root 3 over 3. So that's how I rationalize the denominator of 1 over root 3. So let's look at the next example. In this example I've got 1 over the cube root of 2. So what must I multiply the top and the bottom by to get something rational in the denominator? So I want to hopefully end up with a 2 in the denominator. So how do I do that? Well, I've got to multiply it by the cube root of 2 twice. So this is the same thing as 1 over the cube root of 2 times the cube root of 2 over the cube root of 2 times the cube root of 2. It's the cube root of 2 over the cube root of 2. This is the same thing as the cube root of 2 squared, but 2 squared is 4, so this is just the cube root of 4. And on the bottom I've got the cube root of 2 times the cube root of 2 times the cube root of 2, which is just the cube root of 2 cubed. And the cube root of 2 cubed is just 2. So that's 2. So that's how I rationalize the denominator of this one. Now let's look at 1 over root x. I'm going to multiply the top and the bottom of this by root x. So 1 over root x is the same as 1 over root x times root x over root x, which is root x over root x times root x, which is the square root of x squared, which is just x. So that's another neat trick for you to know about. So if I've got 1 over root 2, for instance, that's the same as root 2 over 2. It just saves you some time. So in the next example, I've got to find or rationalize the denominator of 1 over the square root of 7 minus root 3. So what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the square root of 7 minus root 3. So if you don't know what that means, when I multiply the conjugate, I change the sign of this. So for instance, the conjugate of root 7 minus 3, if I take the conjugate of this, so the conjugate, then the conjugate of this is just root 7 plus root 3. Likewise, if this was root 7 plus root 3, the conjugate of that would be root 7 minus root 3. So if I have this and I multiply the top and the bottom by root 7 plus root 3, what do I get? Well, I got root 7 plus root 3 divided by root 7 minus root 3 times root 7 plus root 3. This is the same as root 7 plus root 3, but you notice on the bottom I've got the difference of 2 squares. If I've got something in the form a minus b times a plus b, that's the same as a squared minus b squared. So in this case I've got the square root of 7 minus the square root of 3 times the square root of 7 plus the square root of 3. This is the same as 7 minus 3. And if you don't believe me, I encourage you to pause the video and expand this expression. And 7 minus 3 is 4, so this is just the same as the square root of 7 plus the square root of 3, all divided by 4. So let's look at our final example. We're asked to rationalize the denominator of 1 over root 6 plus root 3. As before, we're going to multiply the top and the bottom by the conjugate of this number. So the conjugate of root 6 plus root 3, if I take the conjugate of this, so if I take the conjugate of this number, that is root 6 minus root 3. So if I go back to my example, I'm going to multiply the top and the bottom of this by the conjugate. And the conjugate is root 6 minus root 3. So this becomes root 6 minus root 3, all divided by root 6 plus root 3 times root 6 minus root 3. And again, using the difference of two squares, I can tell what this is what's going to happen. So this is root 6 minus root 3 divided by something. Well, I've got root 6 plus root 3 times root 6 minus root 3. This is again the difference of two squares, and this in this case is just root 6 squared minus root 3 squared, or 6 minus 3. So that's root 6 squared minus root 3 squared, which is 6 minus 3. That's the same thing as the square root of 6 minus the square root of 3 divided by 3. So that's how I rationalize the denominator of this fraction.